A gold nugget does not choose where it stops. The landscape chooses for it. Long before a prospector arrives, mountains fracture, rivers abandon their channels, deserts swallow ancient waterways, glaciers tear valleys apart, and storms move sediment that may have remained untouched for centuries. Gold simply responds. It falls, it settles, and because it is extraordinarily dense, it tends to remain where moving water, gravity, and erosion finally lose the power to carry it farther. That means the greatest question in prospecting is not simply, where is the gold? It is, where did the landscape force the gold to stop? Across the United States, there are places where that question has been answered repeatedly. Some became famous during the 19th century gold rushes. Others sit beneath desert sun. Some are frozen for much of the year, and a few preserve evidence of rivers that disappeared millions of years ago. Today, we are crossing 7 very different American landscapes to understand where natural gold can become concentrated, why nuggets appear in some places but not others, and what the ground itself can tell you before a pan or detector ever comes out. And our journey begins where one of the most consequential gold discoveries in American history changed California forever. 1. The Sierra Nevada. California stands beside the American River today, and nothing about the water announces what happened here. The river moves through granite boulders, pines climb the surrounding slopes, gravel shifts beneath the current. It looks peaceful. But in January 1848, near Coloma, a carpenter named James Marshall noticed metallic material while inspecting the tail race at Sutter's Mill. The discovery helped ignite the California gold rush. Hundreds of thousands of people eventually poured toward California, yet the river itself had not created a single grain of that gold. It had only revealed it. To understand why, we have to move upstream and backward through time. The Sierra Nevada contains extensive belts of metamorphic and igneous rocks cut by mineralized structures associated with California's famous Mother Lode region. Deep geological processes introduced gold into fractures and veins. Then uplift raised those mineralized rocks toward the surface. Weather attacked them. Rock fractured. Streams carried the broken material downhill. And eventually, gold escaped. That is the first landscape lesson. A productive placer system needs a source. But a source alone is not enough. Once gold enters a stream, the river begins sorting it. Sand moves easily. Gravel requires more energy. Gold behaves differently because its density is far greater than most surrounding sediment. During powerful floods, even gold can move. But when water velocity decreases, the heaviest particles tend to drop earlier than lighter material of similar size. This creates places where gold can become concentrated. Not everywhere, specific places. Imagine floodwater roaring down a Sierra Canyon. A nugget is moving with cobbles and gravel. Ahead stands an enormous boulder. Water accelerates around it, but immediately behind that obstruction, flow conditions change. The nugget can fall into the quieter zone. Another flood arrives. More sediment moves. The nugget may shift again. Eventually, it reaches a fracture in exposed bedrock. It falls inside. Now the river has a problem. The crack is narrow. The gold is heavy. Water continues overhead. The nugget remains. That is a natural trap. And once you begin thinking in terms of traps, a river stops looking like a continuous strip of equally promising gravel. It becomes a map of changing energy. Inside bends can matter because flow velocity may decrease relative to the outside of a bend. Bedrock irregularities can matter. Natural riffles can matter. Crevices can matter, but none of these automatically contains gold. They become interesting when they occur within a genuinely gold-bearing drainage. That distinction is crucial. A perfect-looking bedrock crack in the wrong watershed is still just a crack. The geology upstream comes first, and California hides another clue above today's rivers. Old river channels. During the 19th century, miners discovered that some rich gravels were sitting far above modern streams. At first, that seemed strange. Why would river gold occur on hillsides? Because the river had moved. Over geological time, drainage systems can be diverted, incised, buried, or abandoned. A channel that once occupied a broad valley can eventually be left high above a younger river cutting deeper below. These ancient gravels preserve an older landscape, and in parts of the Sierra Nevada, ancient placer deposits became major mining targets in their own right. This completely changes how we read gold country. The river you see today is only the newest version. there may be another river written into the hills above it, and sometimes the older river carried the richer story. But California gives us only one version of that process, because hundreds of miles southeast, water becomes scarce. Forests disappear, permanent rivers become uncommon, and gold hunting enters a landscape where the most important stream may be one that hasn't flowed properly in years. 2. Gold Basin and the Mojave Desert Country. Arizona. The Arizona desert looks empty until rain arrives. Then it reveals its memory. A dry wash that appears lifeless for most of the year can suddenly become a violent stream. Water rushes between boulders. Sediment moves. Banks collapse. Material that has been resting for decades can travel again. Hours later, the water may be gone, but the sorting has already happened. This is one reason desert prospecting requires a different way of thinking. In a perennial river, water is constantly reworking sediment. In the desert, concentration may occur in short, violent episodes separated by long periods of stillness. Gold Basin in northwestern Arizona near the Nevada border became known historically for placer and lode gold, and the surrounding desert terrain provides a useful example of how gold behaves outside the classic forested river environment. Here, the landscape is open. Sparse vegetation exposes the ground. Ridges weather directly into washes, and detectorists can sometimes search surfaces that would be hidden beneath soil and vegetation elsewhere. But the obvious wash bottom is not the only place worth understanding. Look at the slope. Look at where material enters the wash. Look at old terraces. Look at shallow channels cut into hard ground. And most importantly, look at elevation. A modern drainage tells you where water moves now. An older bench may tell you where it moved before. Gold does not care which channel is currently active. It remembers every channel capable of transporting it. Desert erosion can also leave something behind through a process almost opposite to river transport. Wind and sheet wash preferentially remove finer, lighter material from exposed surfaces. Heavier fragments can remain. Over long periods, a stony surface known as desert pavement may develop. In favorable gold-bearing terrain, repeated removal of lighter material can sometimes help concentrate heavy particles relatively near the surface. This is one reason metal detecting became so closely associated with nugget hunting in parts of the American Southwest. The prospector is not necessarily waiting for gold to appear in a pan. They may be searching the old erosional surface itself, but there is an important correction to one of prospecting's oldest myths. Quartz does not automatically mean gold. Iron-rich rocks do not automatically mean gold. Red soil does not automatically mean gold. Those features are common across enormous areas where economically meaningful gold is absent. Context is everything. What matters is whether those features belong to a mineralized system known to contain gold and whether erosion has had an opportunity to release and concentrate it. A detector can tell you metal is beneath the coil. The landscape tells you whether searching there made geological sense in the first place. And in Arizona, another clue is easy to overlook: the small drainage. A broad wash attracts attention because it looks important. But small tributaries draining directly from mineralized slopes can sometimes provide a much shorter connection between source and concentration. Imagine gold being released from weathering rock only a short distance uphill. It does not need to travel miles. A seasonal storm carries it into a narrow drainage. The water loses energy against exposed rock. Heavy material settles. The journey may have lasted only minutes. That is a very different story from gold that traveled through a major river system for thousands of years. And it leads us toward a broader principle. Sometimes the best clue is not where the gold ended up. It is how far it could realistically have traveled, which brings us north to Nevada. 3. Nevada's Great Basin, where gold can remain. Close to home. Nevada is famous for gold, but much of its modern gold story is not a nugget story. It is a story of enormous deposits containing gold too fine to see easily with the naked eye. That matters because a prospector can make a serious mistake here. A region can produce tremendous quantities of gold commercially while offering relatively poor conditions for finding large natural nuggets. Scale does not guarantee nugget size. Geology controls that. Still, Nevada contains historic placer districts and localized areas where coarser gold has been recovered. And its landscape teaches perhaps the most important lesson in this entire journey. Follow the source relationship. Across the Great Basin, mountain ranges rise abruptly from broad desert valleys. The geometry is striking: ridge, basin, ridge, basin, again and again toward the horizon. When mineralized rock is exposed in one of those ranges, gravity and episodic water begin moving weathered material outward. At the mouth of a canyon, the slope suddenly decreases. The confined drainage opens onto the valley. Water spreads, velocity falls, sediment drops. Over repeated flood events, this can build an alluvial fan. From above, it resembles an enormous cone spreading outward from the mountain front, and somewhere inside those sediments may be a record of everything eroded from the drainage above, including heavy minerals, potentially including gold. But an alluvial fan can be enormous. Searching randomly across it would be inefficient. So we return to the same question: where did energy change? Old channels crossing the fan can matter. Bedrock exposures can matter. Places where a wash cuts through older gravel can reveal buried layers. Tributary junctions can matter. But again, these are not universal gold formulas. The upstream mineralization must support the possibility first. This is where modern prospecting becomes less romantic and much more intelligent. Historical mining records, geological maps, land status information, old placer reports, known mineral districts. These can reduce thousands of square miles of desert into a much smaller set of plausible landscapes. Then field observation takes over. Not every old gold district remains open to recreational prospecting. Claims, private property, protected lands, tribal lands, and local regulations matter. A location can be geologically fascinating and legally unavailable. So the first tool is sometimes not a detector. It is research. And that itself represents a major evolution from the 19th century gold rush. Early prospectors often followed rumors. Modern prospectors can follow data. But there is one American landscape where even excellent maps cannot remove the greatest obstacle. Because there, the ground itself may remain frozen. 4. Alaska, the last great placer frontier. In Alaska, scale returns, not the industrial scale of a giant mine. The scale of wilderness. Mountains stretch beyond roads. Rivers cross country with no towns for enormous distances. Winter locks the ground. Summer releases it. And gold occurs across multiple famous placer regions, including the Fairbanks District, the 40-mile country, and the Seward Peninsula. But perhaps no Alaskan gold landscape is more visually surprising than Nome. Because here, the gold reached the sea. Stand on the beaches along the Seward Peninsula, and the idea seems almost contradictory. Waves roll onto dark sand. The Bering Sea stretches toward the horizon, and mixed through portions of those coastal sediments is placer gold. How does mountain gold end up on a beach? The answer requires the entire landscape. Gold erodes from mineralized source rocks. Streams transport it toward lower ground. Coastal processes rework the sediment. Waves and currents repeatedly sort grains by size and density. Lighter material moves more readily. Heavy minerals can become concentrated into darker layers, and gold, because of its density, may become part of those placer concentrations. The beach becomes a sorting machine. But the visible shoreline is only today's boundary. Sea level has changed dramatically through geological time. During Ice Age periods, enormous quantities of water were locked in continental ice sheets, lowering global sea level. Parts of today's continental shelf were once dry land. Drainages extended farther outward. Later, rising seas submerged those landscapes. This is one reason offshore placer mining became part of Nome's modern gold story. Some of the landscape that once carried gold is now underwater. The river did not necessarily disappear. The ocean moved over it. That is a remarkable prospecting lesson. Today's geography can hide yesterday's gold traps. And farther inland, Alaska adds another complication: permafrost. Frozen ground can preserve old placer deposits beneath layers that remain locked for much of the year. historic miners encountered permanently frozen gravels and developed ways of thawing ground to reach buried pay. Modern operations use very different equipment, but the geological principle remains. Gold can survive in ancient sediment long after the surface environment changes completely. Then there are Alaska's active streams. Here, the same placer rules return, but amplified by enormous seasonal changes. Snow melt increases discharge. Floods rearrange gravel. Ice can scour channels. Boulders move. Bedrock is exposed and covered again. A place that looked uninteresting one year can appear completely different after major high water. The landscape resets portions of the search area. That is why gold prospecting is never simply about memorizing a location. It is about understanding a process. But Alaska's glaciers introduce another process entirely. Ice does not sort material like flowing water. A glacier can carry everything: clay, sand, boulders, mineralized rock, potentially gold. It crushes and transports material with little concern for density. Then meltwater takes over, and only then can hydraulic sorting begin concentrating the heavy fraction. That transition, from unsorted glacial debris into sorted stream sediment, can create complex placer environments. The prospector is no longer reading only a river. They are reading what ice did before the river existed, and if that sounds complicated, our next landscape preserves an even older puzzle. Because there, the richest channel may not contain water at all. 5. The ancient channels of California's mother lode country. Imagine climbing a hillside hundreds of feet above a modern river and finding rounded river gravel, not angular fragments from the slope. Rounded cobbles, water-worn stones, material that clearly spent time inside moving water, yet there is no river anywhere near you. That is when the landscape begins telling its secret. The river is gone. During earlier geological periods, drainage networks crossed parts of the Sierra Nevada very differently from today. Some ancient channels accumulated gold-bearing gravel. Later volcanic activity buried portions of those channels beneath lava flows and volcanic deposits. Tectonic uplift and erosion changed the landscape again. Modern rivers cut new valleys. The ancient channels remained stranded above them. 19th century miners eventually discovered some of these buried placer systems and pursued them using hydraulic mining and underground drifting. The scale of some historic operations became enormous and environmentally destructive enough that hydraulic mining became the subject of landmark legal restrictions in California. But geologically, the ancient channels revealed something profound. Gold can outlive the river that concentrated it. Think about what that means. A prospector looking only at modern water sees only the latest chapter. A geologist looking at gravel high on a ridge may see an entire vanished watershed. The clue is not gold itself. It is misplaced sediment, rounded cobbles where no modern stream should have left them, layers of gravel beneath volcanic material, old erosional surfaces preserved above current valleys. These features allow landscapes to be reconstructed backward. Where did the old river flow? Which direction did it travel? What mineralized terrain did it drain? Where would its high energy and low energy zones have occurred? Suddenly, prospecting becomes geological archaeology. You're searching for a river that exists only in fragments. And this is exactly why claims such as gold is always in the lowest point can be misleading. Lowest relative to what? Today's valley, or a river channel buried millions of years ago, hundreds of feet above it. The landscape has changed. Gold may not have. And from California's buried rivers, our journey now moves toward a place where water did something different. Instead of carrying gold toward an ocean, it carved through some of America's most famous gold country and repeatedly rearranged the deposits left behind. 6. Colorado. Colorado's Rocky Mountain gold country. Colorado gold carries two identities. One belongs underground. Hard rock deposits, veins, historic mines. Mountain districts where miners followed mineralization directly into stone. The other belongs downstream. Places where erosion dismantled portions of those mineralized systems and water redistributed the liberated gold. Clear Creek became one of the important early placer regions during Colorado's gold rush. Farther into the mountains, historic districts such as Central City and Idaho Springs became synonymous with hard rock mining. But for our purposes, the relationship between the two matters more than either one alone. Source and trap. The mountains provide the source. The drainage provides the sorting system, and Colorado makes that relationship unusually visible because elevation changes so quickly. Snow accumulates high in the Rockies, spring arrives, meltwater increases stream power, sediment moves, then discharge falls. Material settles again. Repeat that process across centuries and the stream becomes an enormous natural concentrator. But mountain rivers are chaotic. They do not behave like laboratory sluices. Channels migrate. Floods remove old deposits. New gravel bars form. Boulders create temporary traps. Bedrock becomes exposed, then disappears beneath sediment again. This means one of the most valuable skills is learning to distinguish a place that merely looks good from one that fits the history of the drainage. Suppose you find black sand. That tells you heavy minerals have concentrated. Useful information. It does not prove gold is present. Suppose you find quartz. Useful geological context in some districts. Again, not proof. Suppose you find an inside bend. Potential trap. Still not proof, but now combine them with a drainage known historically to carry placer gold, exposed bedrock, evidence of high-energy flood transport, and a natural low-pressure zone. The probability has changed. That is the difference between collecting signs and building a geological argument. Professional exploration works this way at a much larger scale. No single clue proves an ore body. Multiple independent clues strengthen a model. The recreational prospector can borrow the same logic, not by pretending to know exactly where gold is, but by systematically eliminating ground where it is less likely to be concentrated. Colorado also reminds us that the best-known locations can be legally complicated or heavily worked. Historic fame does not equal unrestricted access. Modern prospecting requires checking ownership, active mining claims, local rules, and collection restrictions before disturbing material. That is not separate from successful prospecting. It is part of it. And now we come to our final American landscape, a place that changes the entire visual language of gold hunting. No towering Sierra forests, no Alaskan permafrost, no Colorado snowmelt. Instead, red rock. Open sky, dry channels, and an ancient geological history written across the desert's southwest. 7. The Bradshaw Mountains and central Arizona gold country north of Phoenix. The Bradshaw Mountains rise from the desert like an island of broken stone. Today, much of the landscape feels dry and exposed. But beneath that surface lies a long history of mineralization, mining, erosion, and placer activity. Historic districts around places such as Lynx Creek near Prescott became known for placer gold. And this final landscape brings together nearly every lesson from our journey. There is source rock in the mountains. There are drainages capable of transporting weathered material. There are narrow bedrock sections. There are broader washes. There are older surfaces above modern channels. There are storms powerful enough to rearrange sediment dramatically. And there is one thing every prospector eventually learns. The obvious place is not always the place where gold stopped. Picture a desert wash immediately after a major storm. Water has torn through it. Fresh gravel lies exposed. Branches are wrapped around shrubs. Sandbars have moved. The wash looks completely different. Most people naturally search the easiest sediment. But gold responds to hydraulics, not convenience. Where did the fastest water slow? Where did large rocks accumulate? Where does exposed bedrock interrupt the channel? Where are cracks oriented in ways that could retain heavy material? Where does a tributary enter? Where does the channel suddenly widen? And what lies upstream? That last question may be the most important. Always upstream, because every placer particle has a history. If you move backward through that history, you move toward the source. Gold becomes coarser in some systems as you approach source areas, though real deposits can be complicated by multiple episodes of erosion and transport. Angular particles may suggest less transport than flattened, well-worn pieces. Quartz attached to gold can sometimes indicate relatively limited liberation from its source. None of these clues should be interpreted alone. Together, they begin telling a story, and that story is exactly what the 7 landscapes have been teaching us. California showed us that rivers can concentrate gold. Arizona showed us that rivers do not need to flow year-round. Nevada showed us how mountains feed desert basins. Alaska showed us that coastlines, glaciers, and changing sea levels can completely rewrite placer geography. The ancient Sierra channels showed us that a gold-bearing river can disappear while its deposits remain. Colorado showed us the importance of connecting source geology with downstream traps. And here in central Arizona, all those ideas converge. Because gold prospecting is ultimately not about memorizing secret locations. Secret locations eventually become crowded. Coordinates get shared. Claims change ownership. Rivers move. Storms rewrite washes. What lasts is the ability to understand the landscape. A nugget lying beneath gravel today may have begun its journey millions of years ago. First locked inside rock, then exposed by weathering, released, moved, buried, moved again. Perhaps carried by a river that no longer exists. Perhaps trapped beneath sediment. Perhaps uncovered by a flood only last winter. By the time a human hand finally picks it up, the final moment may last only seconds. But the journey behind it could span geological time. And that changes the meaning of prospecting. You're not simply searching for yellow metal. You are reconstructing movement. Mountain to slope, slope to tributary, tributary to river, river to trap, source to destination. Every landscape removes possibilities. Every clue narrows the search. And eventually, if the geology is right, the access is legal, the research is sound, and patience survives long enough. The landscape may leave something behind. Not because it wanted you to find it. Not because there is gold beneath every quartz vein or every black sand streak. And certainly not because every promising-looking creek contains nuggets. But because gold follows physical rules. It has weight. It has a source. It has a transport history. And somewhere along that history, it has to stop. So the next time you stand beside a mountain creek, walk across an Arizona wash, examine an abandoned terrace, or notice rounded gravel sitting strangely high above a modern river, don't begin by asking, where should I dig? Look around first. Read the slope, read the rock, read the drainage, reconstruct what the water used to do, and ask the question that changes prospecting from wandering into discovery. If gold traveled through this landscape, where would the earth have forced it to stop? Because somewhere across America's gold country, another nugget is still sitting exactly where the landscape left it. The river may have moved. The mountain may have changed. The people who first searched there may be long gone, but the gold may still be waiting.